Good evening, class. Today I'm gonna go over this exam. I think some of the problems that we did in class, we did too fast and we made some silly mistakes, or I made some silly mistakes. Here, for example, the first one, right? I think that one we did right. So this is log b of 5 minus log base b of r, right? So in this case, this one is wrong, right? It should be this way. So this is false, right? It's not true. The second one, you have to be careful. You have to be very careful in this exam. Look, they give you log b u and everything to the r. That's not the rule. The rule will be like this: log base b of u to the r, and then you can move r log b u. But that's not this, right? Like that's not like this, right? It's this thing is saying everything, right? Everything to the r. So you have to be careful. So this is not true. So this is false. Okay, be careful though. So this is false. Okay, it should be, if it was like log b u to the r, then you can say r log base b of u, then that would be right. But in this case, that's not right. So this is false. Okay, the second one, here we have log b of a and log b of c. This is not that. This will be, let me put in different color. This will be like this, something like that, but not like this one in yellow, right? So this one is log c of a. You can think about this denominator as your base and this numerator as your number. This is called the change of base formula. Change of base formula, okay, for logarithms. So here, this is different than this. Don't get confused those things, okay? So here we can use, this is a quotient rule, so we can use log b of 5 minus log b of r, but this is not the quotient rule. This is the change of base formula. Be careful, okay? So this one, in this case, is false, right? And the last one is also false, because here we have to do, you see the difference between this b and this one? You see now the t is where it's supposed to be. So now I can do that, the thing that I was talking about before. So I can say t log b a b. And now this is distributing all the terms inside. So this is going to be t log b of a plus log b of b. And this is everything, right? So this is going to be t log base b of a plus 1, which times t is just t, right? Be careful though, be careful. So this is also false. So everything was false. Be careful though. Okay, for the piecewise function, look, this is the way you're supposed to see it. So when x equals -2, right? What's f of x? So when x equals -2, what's f of x? Well, in this case, it's -4. So when x equals -2, x is -4. However, this is inequality, right? So it goes to the left, because you can think about what numbers are less or equal than -2. Well, -2, -3, -4, -5, -6. It should be all the way to the left. So that's the reason this graph looks like that, right? Now, that one wasn't that bad. Now, for the second part, you have to plug -1 in f of x. So if you plug f of -1, notice that this is not included, right? So f of -1, it would be -1 minus 2, which is -3. So when x, let me put that in blue so you get only confused. When x equals -1, the y value is -3, but it's not defined at that point, right? Right here. Now, when f of 2, right, when x equals 2, then what's the y value? So it will be 2 minus 2 is 0. So when x, this is x, right? When x equals 2, the y value is 0. So that's also undefined because, look, I'm using these boundaries, right? Right? So that's the reason that that's not defined. If it was like this, I will have to include, right? I will need to circle it like this. But if it's not included, I will have to put the circles like that, right? And that's a graph. And somebody was, I think Thomas was asking me in the class, I can use a y-intercept method. Yes, you can use a y-intercept method. So in this case, if you're using the y-intercept method, right? So you know when you're looking for the y-intercept, you need to set x equals to 0, right? So when x equals 0, this is y. That would be 0 minus 2. So this is negative 2. So therefore, this point should be included in your graph, right? It's not necessary to do that, okay? It's not necessary. Now, what's next? We need to do the linear function, right? The last function from the piecewise function. That one, when x equals 3, so f of 3, and this point now is included, it's negative 2 times 3 plus 4. So that's going to be negative 6 plus 4, which is going to be negative 2. So when x equals 3, right, and that point is included, right, then the value is negative 2. So that's right there, right here, right? Now, if you want to plug another point to make your graph look nicer, you can put 5, let's say, negative 2 times 5. So when f of 5, it will be negative 2 times 5 plus 4. That's going to be negative 10 plus 4 is going to be negative 6, right? So negative, when x equals 5, this is negative 6. And then you graph your line. And that's the end of this, right? It's not that difficult. Okay, next. A lot of these problems we did in class. I'm going to go over really quick. So here, the trick with exponential functions, I have to make them the same base. I have to make them the same base. So this is 3 to the 2x, and we said that in the class that this is 3 to the 5, right? Because 3 to the 5, it's 243. So you set the exponents equal to each other. Once you have this situation, you need to set the exponents equal to each other, right? So in this case, it's m equals n. So in this case, it will be just 5. Divide by 2, and you get 5 halves. That's it. That's all you have to do. Okay, and you have to look for extraneous solution. There's only one solution. If you plug that in, that gives you 243. Okay, this one. Okay, so let's see what happens here. So this is going to be 2 to the third x equals 2 to the 1/2, right? Remember, square root of x is the same as x to the 1/2. This denominator goes in the index. This is called the index, right? So whatever this denominator is, whatever that is, it goes on the index, right? Because this is a square, you don't need to put the 2 inside the square root. But if it was, for example, x to the 1/3, then you will have to put the cube root here of x, right? And if this was a square, let's say, you will have to put square here, or you can put it here this way. It's up to you, right? So let's solve the problem. So now that we have that, we can set this equals 2 to the 3x equals 2 to the 1/2. Now, you have the same base. Now you can set up the exponents equal to each other using this rule from here, right? So I need to multiply by 1/3, right? And that should be my answer. X equals 1/6. Okay. I hope you understand that. This one. So here we need to factor 5x. This is going to be 2x cubed minus ax equals to 0. 5 to the x equals 0. 2x cubed minus ax equals to 0. Let's factor this first. 2x, x squared minus 4 equals to 0. X, 2x equals to 0. X plus 2, x minus 2. And you might say, where do you get that from? From the difference of squares, right? A squared minus b squared equals a plus b, a minus b. I told you to memorize this thing, right? And in this case, x will be, a will be x, and b will be 2. And now you just use the formula x plus 2, x minus 2, right? So that's what I did. So this is equal to 0, x equals to 0, x equals -2, right? If you set these parentheses equal to 0, then that's what you get, right? And then if we do the other side, x minus 2 equals 0, add 2 in both sides, you get 2, right? Now you need to solve for this one too, right? This one right here. That one, you cannot, it's undefined, right? Because this is like exponential function. And the only way to solve that is doing, you have to move this to the front. So that's going to be x. You can do ln if you want, ln of 5, and then ln of 0. Or you can do log if you want, doesn't matter. So here, ln of 0 is undefined. So therefore, I cannot solve this equation. So that I can just cross this out. So the solution will be these two. These three, I'm sorry. These three. 1, 2, 3, right? That's the answer. Next. So here I have the same base of the logarithm. I have log base 2, log base 2. So I can put them together. And since I have addition, I can use the quotient, right? So this is x plus 2 equals to 3. Now I can use an exponential function, right? I can say that this is 2 to the third equals x plus 2. So therefore, this is 8x squared plus 2x. Subtract a in both sides. This cancels out. I have x squared plus 2x minus a equals to 0, or 0 is here, whatever you want to put it. So this is going to be x plus 4, x minus 2. If you don't know how to factor again, look, you put the parentheses. This sign means that the signs are going to be different. One is plus, one is minus. Two numbers, when you multiply, give you negative 8, and when combined, give you positive 2. So that's going to be 4 and 2, right? 4 times negative 2 is negative 8. And this is 4x, negative 2x, that's 2x. So that's the middle term, right? So that now you solve the problem, basically. So now you need to set up x equals negative 4, x equals 2, right? Set it equal to 0, each parenthesis. This equal to 0, and this one equal to 0 too, okay? That's how you do that. So if you check for extraneous solutions, right? If you plug this here, then you get the undefined term, right? Log 2 of negative 4. You cannot have a negative logarithm. So this is not, this answer is extraneous. Okay? That's how you can think about this. And this is the only answer. Next. So here I told you in class that this is the same as saying a minus b, a plus b, right? You can think about this as a, right? This is a, and you can think about this as b, this part, right? So that's b. So what you should do, very simple. You can do the difference of squares, but first you need to put the, since you have the same base of the logs, right? You have log b, right? So you need to put them together. You have addition, so you can do as a quotient. So this is log b, and then you have this x squared plus 1 minus x squared plus 1 plus x. Again, this is the difference of squares. Therefore, this is going to be a squared minus b squared is equal to this, right? Now you just do the computation, right? So that's going to be the square of this, right? So the square of that is the same as saying multiply those two, right? So you can think about x squared plus 1 square. You can do this way. So you get x squared plus 1, or you can do x squared plus 1, x squared plus 1. And this is the same as I've been telling you forever. 2 times 2 is 2. 3 times 3 is 3, right? 4 times 4 is 4, right? Like this square root thing. So this is going to get the, you're going to get the inside, right? You're going to get the inside. So that's going to be x squared plus 1. Now you can FOIL it, right? So that's going to be this guy times this guy, right? So that's going to be x squared plus 1. And then you're going to get, actually this is plus, right? And then the other one is going to be minus. I'm doing this one with this one, right? And the last term is just x, negative x times x. That's going to be negative x squared. So these cancel with this, right? These cancel with the x squared. So you have leftover log b of 1. And you know the log b of 1 is 0. So that's it. That's the end of that problem. Now this one. This one is a pain, right? We were having trouble because I have to do it on the board, and when I have to do this on the board, it's a little bit uncomfortable. Okay, give me 1 second. Let me explain to you. This is the most difficult part of this thing, right? Because it's annoying a little bit, but it's okay. We can do that. That's not difficult, right? It's easy. Okay, let me explain to you really fast. What's the strategy? Remember I told you in class, I'm gonna give you a strategy. Okay, look, the strategy is the following. I know right now that C and D are the one that has the vertical stretch the highest, let's say, right? Vertical stretch means like for example, you have something like this, right? The vertical stretch is more like kind of steeper, like steeper and steeper, something like that, right? If it's growth, right? So for example, right, the first thing I should do is look at C and D. So the only ones that they have the vertical stretch the highest is these two, this and this. One is a growth and one is a decay, right? This guy is a growth and this is a decay. So now the one that is a growth, it should be going something like that. So let's check that one. So you know it's D right away, this one, right? This one is D. So let me copy this and put it over there so you can see what's going on. Copy and then put it here. Okay, so this one is D. Okay, that one is D because it has the growth, because it's 1.28. Remember, the growth is anything A have to be greater than 1, right? And in this case, we have 1.28, so we know that this is exponential growth. Okay, and then the other one is decay, right? So it should be C, right? Because this is decay and it has the highest vertical stretch, right? So that means that this is decay, and we can just plug. Okay, copy and paste here. Copy, and that's the strategy so far. So it's working out nicely. So we're not spending too much time doing this thing. Okay, good. So those are those two. Now I need to focus. There's 2 growths and 2 decays, right? So we have this guy here. These are growths, right? And one is steeper than the other. So that means that this E should have what? The bigger A, right? So whatever, like you have the exponential functions are this written in this form, right? A to the X. So that means what this A should be what? Should be like big, right? If this is bigger like than this A, right? These both are greater than 1. However, whoever is bigger, it's telling you basically it grows faster. It has an exponential growth, like the rate is faster than the other. The growth rate is faster, right? So here basically we need to check these two, the growth. So we have to check the only two that they have a growth. So here the only one that they have a growth is let's put that in different color. So growth is this and growth is this. So I told you, right? The one that has the highest A, it should be the steeper one, sort of, right? So I can copy this and I can say that this one is E, right? Because it has the higher growth rate. And then the other one is F, right? So what is that? Yeah, this one, right? This one. Copy. And this is paste. So this one is, it has a slower growth rate, right? So you see this one has a higher growth rate, this has a lower growth rate. So now we have, the bigger one is E. Oh, I forgot to put that, right? So the growth was, let me erase this. So this one was D, and this one was C, right? This is C, yeah, C. Okay, so that's the strategy so far. And then this one is E, the 1.59, that's E. And then the other one is F, the 1.28, okay? Now we have the other two left, right? The A and B. So we know it's decay because they're both growing down. Now, let's do this. So remember, this is decay, right? So the one that has the slowest how can I say this? The slowest decay rate, it should be this one. So okay, so this one should be this. Why? Because this one has the slowest decay rate, right? And this one, this 2.81 has the faster decay rate. So it decays faster, right? So that's how you're supposed to think about this. So this decays faster, right? This is the exponential decay, but this decay is faster and this decay is slower. Therefore, B should be 0.69 and then A should be 0.81. I think that is very useful. Please watch this video as many times as you can if it doesn't make sense to you. It's not that hard, it's just the class was annoying because I didn't have the tools and and I was not looking at the paper like at 100%. Okay, this is just graphing, right? More graphing. Okay, let's do this from scratch. Okay, here they say sketch the graph of the given function. Be sure to identify any asymptotes. So this is a logarithm function, right? So a logarithm function has vertical asymptotes, okay? So now you need to find the vertical asymptote. To find the vertical asymptote, set this here equal to 0. So x minus 3 equals to 0. If you add 3 in both sides, you get your vertical asymptote. So that should be x equals 3. Okay, that's that. Now you need to find easy values, right? So x, y, just plug two numbers. That's it. If they don't ask for much, right? If they don't say make a table or whatever, make it simple and fast. So now you pick 4 because 4 minus 3 is log 1/3 of 1, right? 4 minus 3 is 1. Log of 1 is 0. So 4, 0. So we have our first point. Good. Now, what other point I can pick? I need to make this in the inside. I need to make it 1/3 so I can apply this rule. Log 1/3, 1/3 equals 1, right? Like log AA, right? Is 1. I need to apply that. So I need to set the parentheses equal to 1/3. So now just compute, right? Add 3 in both sides. This cancels out. So this is going to be 1/3 plus 9/3, which is the same as 3. So this is 10/3. And somebody in the class told me that this is 3.3, which is good. So this is 3.3. And this is 1. When we get 3.3, this is 1, right? That's the whole goal, the whole point of doing that. So 3.3 and 1. So about here, right? So the graph should look something like this. Right. If I cannot make this nice, then you can see the original graph, right? So that's the answer for that. Okay. And I think when I draw it originally, I make it nicer. Let me see. Okay. I'll go back really fast. Let's see. I want you to see the graph, how I make it nicer. That's all. That's it, right? And if I need to find a domain and range, you know what's a domain, right? So the domain will be from 3 to infinity, and the range will be all real numbers because the range is just a y value, right? The range is a y value, so it goes forever up and forever down. Okay, that's it. Next. Same thing. I need to, now, this is an exponential function. The exponential functions, they have horizontal asymptote. So the horizontal asymptote usually is the plus or minus sign that appears here. So here, this is going to be y equals -1. That's a horizontal asymptote. So that is a dotted line. For simplicity, because I don't have time, I'm going to make a straight line. But in the test, you have to make it a dotted line. Okay. And I need to find the values, right, for that. So x and y, right, or f of x. So when x equals -2, this is going to be e to the -2 plus 2. That's going to be e to the 0, right? And minus 1. Any number to the 0 is always 1. 1 minus 1 is 0. So that's going to be 0. And then you need to find another number, right? Let's say 3. Negative 3. Let's say -1. If I put -1, that's going to be e -1 plus 2 minus 1. That's going to be e to the 1. Minus 1 is 2.8. Minus 1 is 1.8. So when -1 and 1.8 is above here, right? And what else? And then we said that -2, 0, right? So -2, 0. So you can see the graph already. It's something like this, right? Like this. That's a graph. And don't forget to put the little things here. What's the domain? All real numbers, right? What's the range? The range will be from -1 till infinity. That's it. Done. This one. Here I need, this is a logarithm. I'm sorry. I don't know what happened. This is a logarithm, right? So you have to think about, let's see, these ones, they have vertical asymptote. So the vertical asymptote should be the denominator equal to 0, right? So that's going to be x equals 0 divided by -1 both sides, right? So that's going to be x equals 0. That's the vertical asymptote. So x equals 0. Now, you need to find out, and if you want to find out the domain, remember the domain is -x greater than 0. So divide by -1. When you divide the inequality by a negative number, the inequality flip, right? So that's going to be 0. So all numbers less than 0, that would be the domain, right? Now, you need to graph this, right? X, Y. So we can put -1, because if we put -1, we get negative ln, -1. So that's going to be +1, which is going to be 0, right? And what else is the other thing? We can use another value. Let's say we use, let's see, we can use -b. If we use -b, we get negative ln, negative b, right? So -b is going to be e negative ln. So ln e is just 1, so it's going to be -1. We did this in class ABS. So -1, 0 is here, and then -b, -2.8, right? And -1 is above here somewhere, right? So the graph should look something like this, right? So what's the domain? We said that already. It's from -infinity to 0, and the range, it should be from -infinity to infinity. Okay, that's the answer. Now this one. This one, same thing, right? This is an exponential function, so it has a horizontal asymptote. Y equals 1, right? Y equals 1. Now I need to plug the horizontal asymptote. So y equals 1. Oh my God, y equals 1. You get the point. Y equals 1. Okay. And then we need to plug values again, right? So x and y. So we can plug -1, 81, and 81 makes a -2. Actually, plug 0 better. So that's going to be e to the 0 minus 1. So it's going to be e -1, and 81 is going to be a +1. And then we have 1 minus e, right? So that's going to be -1.78. If you don't know what I'm doing, it's 1 minus 2.8, 81.8. Yeah, -1.8. Okay, so that goes 0, -1.8, 0, -1 above here. And then we need to plug another one, right? So we can use 1. If we put 1 here, that's going to be 1 minus 1, that's 0. Any number to the 0 is always 1, and 1 minus 1 is 0. So we can find the other point, 1, 0. So you get the idea how this graph look like this. Okay, something like that. Okay, so that's the graph. What's the domain? Domain is all real numbers. The range is from negative infinity to 1, right? That's it, done. Now this one, I think I did some in class. Here, find the inverse, right? So we have the original function. We need to find the inverse. The only thing when you're finding the inverse, you need to first, you know that f of x is y. So switch f of x for y. So e to the 2x minus 3. Now you need to switch this or swap the variables between x and y. So that's going to be now, it's going to be x. So yes, x equals 2y minus 3. You need to solve for y now. So now you're going to use logarithms. You're going to move this using the power rule to the front. So this is going to be 2y minus 3 ln e, and then ln x in the other side. Now you know that ln e by definition is 1, right? So basically that disappears. Now, now you can add 3 in both sides. So this is ln x plus 3 equals 2y and divide by 2. So y equals ln x plus 3 over 2, which means that this is f inverse of x equals ln x plus 3 over 2. Okay? Now, you need to graph it, right? Because that's what they want in the second part. So I already did that. So I'm going to explain to you how I did it. The first thing, I put my functions already. I have my my ln x here. And I have my ln x. Let me write that nicely, this thing. Ln x plus 3, right? So I graph my original function first, right? So I use, for my original function, I use nice values, right? So I use, well, here you have to use 3 halves, right? Because if you put 3 halves minus 3, this cancels out. So this is e 3 minus 3, so that's e to the 0, which is 1. So when x equals 3 halves or 1.5, right? This is gonna be 1. And then you can put another number. Let's say you pick, let's say, let's see. Okay. If you put, the point is you get 0, right? Or, well, let's see. Well, we want to be able to make this into 1, right? So this 2x minus 3 equals 1. So we add 3 in both sides. So 2x equals 4 divided by 2. So when x equals 2, yeah, when x equals 2, this is 1, right? Because if you plug that here, like the 2, e to the 2 times 2 minus 3, that's going to be e to the 4 minus 1. So that's going to be e to the 1, right? Okay. So when x equals 2, this is e. I made a mistake here. This is e. When x equals 2, this is e. Now you graph it, right? So 1.5 is here. And then 2.78 is there. Okay. So that's the graph for the original function. And remember, the symmetry is around the line y equals x, right? Like I mentioned in class. Now you can use the same method for this graph. So here I can put ln of 1. ln of 1 is 0, right? If I put ln of 1 here, ln of 1, that will give me 0, and 0 plus 3 is 3. 5 times 3 halves is 3 halves. Remember, ln of 1 is 0, okay? ln of 1 is 0, plus 3 is 3, and times 3 halves, times 1 half is 3 halves. So that's what I have here, right? And then I can choose e, right? ln e. Remember, when there's no number here, it's assumed to be e. So ln e is just 1, right? So this is definition. Ln e is 1. So 1 plus 3 is 4, and 4 times 1/2 is 2. So I pick those numbers. So you have 1 and 3/2, and then you have e and 2, right? So I graph that, and that's the graph of the function. So this is the relationship, okay? Make sure that you do this in your house or when you have a time. Okay, the last one. I think this is the last one for this problem. So in your slides, there was this problem, something similar to this problem. So the only thing you need to do for this problem, remember, in your slides, they mentioned that f of x is ca to the x, right? That's the basic, well, this is the basic function, right? But this is multiplied by some, it has a vertical stretch, right? So in this case, we need to find out what is that. So if we use 2 points here, maybe this and this, these are 2 nice points. I have 0, 3. Remember, this is x and this is y. And if I use the other point, let's change the color. What is the other point? 1,6. I can get this function. So let's do the first one first. This is going to be 3 equals c a to the 0. Any number to the 0 is 1, right? I'm using 0 here because x equals 0, right? So this is 0. Any number to the 0 is 1, right? So this is c equals 3. Now I can find out the other one, right? I can find out what is the other value, a. So I know that f of x, and this is f of x, and this is x. F of x is 6, and then c is, well, let's write everything, right? A, and then x is 1, but c I already have, that's 3. So a to the 1 is a times 3 is a, 3a, and then I need to divide by 3. So I have the function equals a equals 2. Now I can write it. So f of x equals c, which is 3. Let me move this a little bit here. 3, and then this is going to be 2 to the x, right? Now, if you want to check, let's check another point that we didn't use to see if this function works. So you can use 2. So f of 2 should be equal to 12. 3 times 2 to the 2, so that's going to be 4, right? That's going to be 12. So this works, right? So this is the function, this one right here. So this is the answer. This is what they want you to write. Okay, and that's it. That's the end of this exam. If you have any questions, please let me know. Have a nice day.